Okay, welcome back to another video on my channel, math_exe, and this is my another problem solving video, and this is where I post some like pretty difficult and quote-unquote difficult problems. Some may be challenging, like this one right here. This is we're going to find the value of log base 1 over k of m squared times log base 1 over m of n squared times log base 1 over n of k squared. And yeah, this equation seems pretty tricky. However, we can make some simplifications right here by first noticing we have some squares right here, and notice we can just take it into the front and turn it into as a multiplication right there. So after extracting a 2, we will get 2 multiplied by another 2. I'll just skip the log, I'll just save it for later. After extracting a 2 right here, multiplied by another 2, and we're left by log 1 over k. Since we already bring out the 2, we're just left with m, and I'll just write log base 1 over m of n times log base 1 over n of k right there. So notice this can simplify into 8. So we need to find what this value is. However, we can just simplify the bases into negative powers, negative exponents I mean. So first we have 1 over k, which is just the same as k to the negative 1 power. We have m to the negative 1 and n to the negative 1. There we go. And we can just make some assumptions by rewriting m and k, m and n by as follows. So we can rewrite k, m, and n as, we can have m is equal to, look at the base, we have k, so we have k to raise to, you may say what power, and the answer is it doesn't really matter as long as you include a is a real number. So next we have n, we can just rewrite as in terms of the base m. We can just have the base of m to the something power, I'll just call it b. And again, this is a real number. We have k itself. We're going to have the base. Look at this. Look at the base. I just forgot that. Look at the base here. We have n, and then raised to what power? We just assume that is c, where c is a real number. And we can make a very quite standard substitution in these three equations I made. So I'll just rewrite this third equation. K equals, I'm going to write the n in blue, I'll just write the c in red. There we go. And notice this n is equal to this n right here. N equals m to the b power. So we can just rewrite this as I'll just again rewrite the m in blue, and don't forget this is to the b, and then we can do parentheses. We can write a parentheses right here, and we have c on the top right there. And notice what is this m right here? It's equal to this thing right here, other side, a bit above right there, so you can see it. So it's equal to m equals k to the a. So we can have, I'll just put double parentheses, k to the a, and parentheses, and close the parentheses, and then we have b, and close this again, and we have c. And notice we have k to the a, and then raised to the b power, and then raised to the c power. Then we can just multiply the powers together to get k to the a times b times c. And notice this is all equal to k right here, but notice we have only k to the 1 power. And what it tells us is we can just remove the k's and we can just assume that a times b times c is equal to 1. And this will be very helpful later. And next step, we're just going to substitute these values right here to our original equation. I'll just rewrite this. So I have a times log base k to the -1 of m. I'll just rewrite this again. Wait, no, this is not to the k. There we go. Okay, so I've rewritten the equation. Now we're going to recall that we just rewritten m is k to the a and is equal to m to the b, and k is equal to n to the c right there. So I can just substitute that in. So equals 8 times log base k, and I'm going to write the powers in red right there, and we have k to the a. And I'm just going to fast forward this after I've written all of that. Okay, so we're done with this, and notice I have written the powers in red, and you see why. Because there is a logarithmic property where we have log base a to the b of a to the c, and keep in mind these powers right here. This is just equal to c over b right there. So we're going to use this property into our equation right there. So this is equal to a. A over -1 is just -a, so I have -a. B over -1 is just -b. C over -1 again, yeah. And notice we can have negative and negative will cancel into a positive, leaving with, I'll just bring the negative into the front right here. So I have -a times b times c. And note what we got from what is a times b and a b c, I mean a times b times c. What's a times b times c? It's just this thing right here is equal to 1. So what it tells us is this whole logarithmic expression, this is equal to -8, and this is the answer right here. So this is pretty scary looking this is a pretty scary looking logarithmic expression right here, but you can just rewrite this with some substitution tricks, and you can just use some logarithmic properties. Actually just one logarithmic properties, just the power logarithmic rule. And I think what makes this problem a bit tricky is how the what do I call it, how the variables are placed. So we have k right here, we have m right here, and it doesn't really match. We have m right here, we have n right here, also doesn't match, and k right here again doesn't match. So that's what I think makes the problem like tricky looking at first, but if you use some tricks, yeah, you can solve it. And that's what math is about. If you know the trick, you can find the solution easily. So yeah, and hopefully guys you enjoyed this video. If you do, please like this video and subscribe for more videos like this. And I'll be posting every day as well. And as always, bye.